This call is now being recorded. This call is now being transferred. Good morning, students. So in today's class, we are going to see about the signal conditioning circuits. We are that's our subject. So we are going in first modules, for a first unit, and today's title is about the application of operational amplifier. Already, two-thirds of the unit has been covered in previous videos, and this is the last portion of unit one. So coming into applications of operational amplifiers, the first application is inverting operational amplifier. So why it is called inverting operational amplifier is if the input signal is being given to the inverting terminal, then it produces an output which is 180-degree out of phase with the input. For example, if the input is in positive half cycle, the output will be in negative half cycle. So that is why we'll call it as inverting operational amplifier. And this is one of the configurations of the applications of the operational amplifier. So what is configurations? We tend to make certain arrangements with an external components. For example, like how we configure our cell phones or configure our laptops in the control panel, we tend to rearrange the components so that it makes some unique functionality. So here in this arrangement, you can see that the terminal from the electrodes is being given to the inverting terminal, that is pin number 2, and there is an input resistance RIN, and there is a feedback resistance RF. What is feedback resistance? It connects the output and the input. That is what called as feedback path. So what happens is these two simple resistors will tend to fix or tend to determine the gain. How do we say that? Let's prove mathematically. So for this, you need to know prerequisite, which is called KCL, Kirchhoff current law, which you would have studied in basic electrical and electronics engineering subject. So coming on to Kirchhoff current law at node 1, say, look at my cursor, let this be node 1 or node A. So applying Kirchhoff current law, what does Kirchhoff current law say? The sum of the current meeting at a point is 0, or in other words, sum of the current entering at a node is equal to the sum of current leaving the node. So coming on to the sum of the current at the node is 0. So let us write the next expression, sum of the current. So what is current? Voltage by resistance according to Ohm's law. So what is the voltage? It is the potential difference between 2 points. So what is the potential across Rn? It is the potential at this point. So in operational amplifier, since the input impedance is infinity theoretically, we tend to say that these two terminals will be at the same potential. Say, for example, if the non-inverting terminal is at 0, the same potential will appear at the inverting terminal because it draws 0 current. It doesn't draws because input impedance is infinity. So here the circuit is said to be in virtually grounded. The pin number 2 or the non-inverting terminal is said to be in virtually grounded. That's because it doesn't draw any current. So here the potential is 0. So coming on to the Kirchhoff current law, 0 minus input voltage. Say the input voltage is V in or Vi, whatever it is. Here I have kept as V in. 0 minus V in divided by Rin. So that is the first expression, plus current. There is no current here, so there is only current leaving. So it is 0 minus the potential here, 0 voltage minus the potential here. What is the potential here? I have kept it as V out or V naught in some books. So 0 minus V naught divided by Rf is equal to the sum of the current at this node is equal to 0. So that's it. In the next step, we can have avoided zeros. So minus V in divided by Rn, minus this minus comes here in general, minus V out divided by Rf is equal to 0. Now what do we tend to do? We tend to rearrange the expressions. So this this term I'm bringing onto the other side. So minus V out by Rf becomes V out by Rf. Minus V in by Rf is equal to V out by Rf. Now what is the next step? I'll try to arrange it in terms, means in a way such that it looks like V out divided by V in. What is V out divided by V in? It is the gain. V out is already here. V in is in this side, so I'll check it to the other side. So it go whatever is in numerator will go to the denominator, and whatever it is denominator, when it comes this side, it becomes in numerator. Look at here. So that's how it has changed. So it is Rf divided by minus Rf divided by Rin is equal to V out divided by V in. Output voltage divided by input voltage. What is output voltage divided by input voltage? That is nothing but it is the gain, and it is actually voltage, output voltage divided by input voltage. So it is called voltage gain. So voltage gain is equal to minus Rf by Rin. So you can see that this feedback resistor Rf and the input resistor Rn determines the entire gain of the overall amplifier. So if we choose the ratio to be 1000, like 1K and 1 ohms, then it is going to be 1000. The gain is going to be 1000. So theoretically speaking, the gain is infinity, and the gain is determined by the feedback resistors and the internal, sorry, not internal, the input resistors. As simple as that. So this is what we'll call it as inverting amplifier. So now coming into the next configuration, which is called as non-inverting amplifier. So wherever inversion of the signal is not accepted or not tolerable, then we'll go with non-inverting amplifier. So there is only a slight change with the gain, nothing else. So in non-inverting amplifier, what we tend to do is we tend to give the input signal from the electrode to the non-inverting terminal, not the inverting terminal. The inverting terminal is grounded through a resistor. So this is still a feedback path because from output to the input side there is a connection. So RF and RIN is there. Now applying Kirchhoff current law at the same node, say take it as name node 1 or node A, gives us an expression for gain. So applying Kirchhoff current law. So as I have told just few minutes back, whatever is the potential at the non-inverting terminal will tend to reflect at the inverting terminal because the input impedance is infinity. So here it is in V in, so this potential will be in V in. So applying KCL at this point, it is V in minus 0, when 0 it is grounded, 0 voltage, divided by RF, sorry, R in, V in minus 0 divided by R in, this term, plus there's no current here, there is only current through the feedback path, that is currently. So it is V in minus V out divided by RF is equal to 0. And the sum of the current at a node is equal to 0. Now what do we tend to do? We tend to avoid the 0 and write an expression. And this RF is denominator is common to V in and V out. So we separately write two expressions, means two terms, V in divided by RF minus V out divided by RF plus V in divided by RN. What we are going to do next, we'll keep V in terminals on one side and V out terminals on the other side, and we'll try to rearrange in a fashion that V out divided by V in comes. So here you can see there are two V in terminals, V in divided by RF and V in divided by RN. And this minus V out divided by RF goes to the other side. So minus V out divided by RF becomes plus V out divided by RF. So V out divided by RF is equal to V in. So here there are two V's which can be commonly taken out. So when we take it out, it becomes 1 plus R, 1 means 1 by RF plus 1 by RN is equal to V out by RF. So now all we need is the final step, arranging it V out into V in. So this V in goes to the denominator of the other side, right hand side, and this RF comes in the numerator of the left hand side. So now what they have done, this RF they have multiplied into both the terminals, both the terms. So RF divided by RF plus RF divided by Rn is equal to V out divided by V in. RF by RF is 1. So it is 1 plus RF divided by Rn is equal to V out divided by V in. So gain AV is equal to 1 plus RF by Rin. It is still RF by Rin plus 1 is added to it. Suppose if RF by Rin is 1000 and in inverting amplifier, in non-inverting amplifier, the same RF and Rin gives 1001 as the gain. One is the gain is slightly increased in non-inverting amplifier. So as simple as that. So that's all about the first unit. So we are done with unit 1 or module 1. So that's it. So if you have any doubt, you can still contact me in person and we can clarify it. And regarding detailed notes, the notes has been, whatever PowerPoint has been circulated has been uploaded in Google Classrooms, whatever I used. And still you can discuss with your friends. And if you don't get it, you can approach me at any time. Thanks for joining. Thank you. God bless you.